History rewards the innovator, the pioneer, the trailblazer. For over 30 years, Supermicro has been fueling innovators and visionaries with the industry's best computing resources. We have built the industry's widest portfolio of storage servers with the largest open ecosystem of leading storage hardware so that you can be first. Welcome to Supermicro's 2025 Open Storage Summit.
Hello and welcome to this episode of the Supermicro Open Storage Summit. I'm Rob Strechay, Managing Director and Principal Analyst. Today, we will discuss enterprise AI and specifically how Retrieval Augmented Generation, or RAG, is influencing enterprise architectures. We're diving into one of the most critical and complex opportunities in enterprise AI. As generative AI moves from experimentation to production, organizations are quickly discovering that real differentiation lies not just in the foundation model itself, but in how well that model can access, understand, and securely interact with their proprietary data. RAG architectures promise to bridge that gap, enabling more accurate, grounded, and context-aware responses by combining LLMs with enterprise data sources. But as we explore this potential, several key challenges emerge. How do you ensure data privacy, compliance, and low latency access? How do you deploy AI where the data lives, often at the edge or in environments where public cloud isn't the right fit? To support these new patterns, enterprises need modern AI-native infrastructure that can scale, secure, and accelerate access to structured and unstructured data across edge, core, and cloud environments. That's the focus of our discussion today. We'll hear from industry leaders, each addressing different layers of the stack needed to make enterprise RAG a reality. From scalable infrastructure for AI/ML workloads to secure local data protection and GPUs to flexible AI cloud environments that support rapid experimentation and deployment, this conversation will explore what it takes to operationalize Gen AI securely, efficiently, and close to your most valuable data assets. With this, I'm so excited to have this panel. We got a great panel going here. The largest panel, I think, in our Supermicro Open Storage Summit. So first off, we have Ben Lee from Supermicro. Then we have Saurabh Giri from VoltagePark. We have Phil Menez from Vast Data. We have Nave Algarisi from NVIDIA. And we have Kelly Osborne from Graid Technology. And lastly, but not least, Tamid Rahman from Solidigm. Welcome to this.
Thank you.
So one of the things that we want to do is kind of get an understanding of where all of you sit in this entire thing. So I'm going to give you an opportunity to kind of fill us in on where you are. Let's start with you, Ben.
Sure, Rob. Thank you for the introduction. I want to start with sharing what we have seen at Supermicro. So last couple of years, we have been helping some large customers to deploy large GPU AI clusters. But recently, what really stands out to us is we are seeing enterprises adopting the AI rapidly. They are not just exporting the inference workload based on the foundation models. They are running some AI reasoning models, time scaling things, and also they are building their own MOE models. So this puts some pressures to the existing enterprise infrastructures and also create a new demand for the next generation enterprise infrastructures. Now you have to consider increased AI flops. You need to have more memory bandwidth and capacities. You need to have a fast neural speed for interconnect. And you need to decide, either it's in the cloud or on premises. So we are seeing a paradigm shift for the enterprise infrastructures. So what's the paradigm shift? I think the true answer is now you need to build anti-AI factories. So at Supermicro, we define 5 layers with a tightly integrated pipelines to assure the data can stream smoothly from the enterprise data and to generate real-time intelligence. So starting from the accelerated compute, now you need to have a GPU accelerated compute, which is typical of the GPU servers. That's really optimized for the token-intensive workload. And then you need to have a high-performance storage to really drive the real-time data access, because the AI model needs to feed these data to generate some answers that for enterprise use, right? And you also need to consider using the storage structured or unstructured data. Then you need to think about the low latency networking. Using Ethernet as an example, you can leverage Spectrum X from NVIDIA, for the scale out, and also the NVLink for the scale up, right? All in all, you just try to create a real-time AI pipelines. Then on the top of that, you need to really have a very strong AI software stack, like NVIDIA Enterprise Suite, NIM or NeMo services, right? Basically, this is really to streamline the software orchestrations for the special AI workloads. Then you have to have a strategy about your LLM. You can be pre-trained LLM, local, based on open source, or you can just call the cloud-based API like OpenAI. But these models, I would say, is pretty much the same like what we've been using for the ChatGPT or Perplexities. That's what we have been using almost every day. But I think the key is most of the enterprise is not yet to connect their own data to these models. So this is the biggest next step, which we will talk about this today. Using the rack to enable all this enterprise data and bring the intelligence to life, so we can unlock a lot of valuable information for the enterprise usage. So I think all our partners today will just try to talk about that. So I will let them to talk about that. But lastly, I want to show this based on the concept from Supermicro. We built a blueprint, try to deliver AI factory infrastructure to the realities. So we no longer just support L10.6 anymore. We also are able to do the rack scale solution. For example, we have a GPU server. We can ship at L10. But on top of that, we can do some AI optimized clusters. We have a very strong product portfolio on the storage side, but we are able also to support the high density storage clusters. So this is all based on our end-to-end in-house engineering capabilities. So we design in-house, manufacture in-house, because we want to deliver performance, quality, and also the power efficiencies. Then, keep that in mind, we work with customers in every single phase. From the planning stage, like floor planning, cooling, rack design, to the real implementation, such as cluster, validation, testing, software loading, validation, and then the on-site deployments. Then even we do the POC, right? So basically, we want to let customers just rely on us as a single partners, so they can deliver turnkey, scalable, and optimized solutions. So that can be either in the cloud or on premises, because our goal or our vision is very simple. We want to simplify the AI infrastructures and accelerate the AI factories deployment globally. Then, make the enterprise embrace the AI faster and with the confidence. Then, we know not everybody wants to build on their own. So that's why we feel it's important to introduce our partner, VoltagePark, to talk about their vision.
Yeah, I think that really is a good thing, because again, you're kind of where the rubber meets the road a little bit here. So really excited to have you here. Why don't you jump in?
Thanks, Rob. So let me introduce VoltagePark, who we are, what we do. VoltagePark is a cloud service provider for AI workloads. We were founded in 2023. We have 6 data centers in the US and offices in San Francisco and Seattle today. And we are growing very quickly. So Ben talked about the different layers that are involved in building out an AI factory. And what we see from our customers is customers want an end-to-end AI stack that's very tightly coupled across the hardware and software layers, because then they get simplicity, predictability, and cost performance. And that is what VoltagePark does. We bring state-of-the-art hardware and couple that with world-class customer service and give this all with incredible value. And on top of that, we provide the software layer that helps enterprises use the AI infrastructure easily and scale quickly from exploration to production. So now I'm going to talk about why VoltagePark partnered with Supermicro and with VAST. Storage is foundational to scaling out AI workloads. Storage throughput directly impacts RAG latency. It impacts training cycle times and overall system cost. Our customers are pushing the boundaries on large-scale training and low-latency inference. So let's talk about training. Large training runs involve a lot of GPUs, and downtime is extremely expensive. From a storage perspective, the single most important aspect is checkpointing frequently, quickly, and reliably. Some of the most sophisticated model builders in the world, the billboards that you see when you drive down the freeway here in the Bay Area, they are customers of VoltagePark. And they are using VAST storage solution that was built by Supermicro. And the feedback we consistently get is that the performance is as good as anything else out there, and in many aspects, much better. Let's talk about inference. Real-world inference use cases like RAG require large amounts of data to be available in real time. Our customers are using VAST storage solution to get world-class read-write performance, and this is foundational to low-latency inference. With that, I'm going to hand it off to Phil to explain how VAST does it.
Yeah, Phil, I think, again, just building on it, I think data is fundamental to anything to do with AI, but in particular with RAG. So, bring us a little more enlightenment, a little bit deeper on what VAST is doing here.
Yeah, absolutely. So as Ben and Saurabh both mentioned, we partnered with Supermicro to build some of the most powerful AI supercomputers on the planet. Customers, as Saurabh mentioned, are pushing the limits of what we thought was physically possible from a performance, scale, and density perspective. So we needed partners that had that type of experience and expertise at deploying infrastructure at scale, but also with the most cutting-edge hardware platforms available. Both Supermicro and VAST have really been in the middle of all of the major AI markets. So one is those model builders, the foundational model builders, which obviously need tremendous speed and scale. VAST has really quickly become the standard in this new generation of service providers. So companies like VoltagePark, they've got the same speed and scale requirements of a model builder, but now I need to bring secure multi-tenancy. I have SLAs around uptime. There's a lot more scrutiny on the functionality that they bring along with that performance. And we've continued to work with our service providers as we've shifted our focus to the enterprise, right? And now AI is making every enterprise a supercomputing center, but they need a whole other set of enterprise functionality on top of that infrastructure. So VAST founded in 2016 with a vision of making thinking machines a reality. That was like written on the napkin business plan, thinking machines. I just love that term. So we really set out to make AI secure, scalable, and easy for every enterprise. And we've just announced kind of the final pieces of our broad vision, which is the VAST AI operating system. So when we see some of the big challenges in enterprise RAG, it's bringing all the different pieces together that customers have to manage to build the total solution. So our vision is to build that bridge between the infrastructure, the hardware, and AI to connect all of those different resources. So the VAST AI operating system brings together the VAST data store. So that's a hyperscale data environment. I give AI fast access to block, file, object data at any scale. We have the database, so now I can capture structured data. I can capture embeddings in real time at virtually any scale. I have the data space, so we are going to have deployments at the edge at our service provider partners. Maybe someone does want to have some workloads in the public cloud. The data space brings that all together. The data engine actually gives you a runtime where I can run embedding services and create data-driven workflows. So if I have a video, I launch the embedding service for video. If I have images, I can launch that proper embedding service. So we've actually taken the VAST Data Engine and worked with NVIDIA, bringing NIMs to create a productized version of a real-time embedding service, which I think is critical for having customers feel comfortable. And then we have the agent engine. We just announced this, going to be available in the next year or so, and that's allowing customers to have an easy interface to build and deploy agents at scale. And when we look at the foundation of the VAST AI operating system, it all comes down to architecture. So we founded our whole company on this disaggregated, shared everything architecture. We call it DAYS, and it's really built from the ground up to tackle the new requirements of what I call the agent era, right? So linear scalability. We have to be able to support hundreds of thousands of GPUs in a single cluster, and we are literally seeing exabyte scale deployments in single clusters now as we're bringing together all of this data. We need real time at scale, right? I want my agents, my users to be able to adapt to what's happening in real time so I can capture vectors, I can do rapid search at any scale in real time. I also need extreme resilience, as Saurabh mentioned, at scale. So we're measuring better than 5 nines real world uptime in some of the most demanding environments on the planet. And it has to be affordable to get all of your data on fast media. And we can do that giving you archive economics with incredibly advanced data reduction algorithms. So I think if you sum it all up, the VAST AI operating system gives you the capability to capture data in real time, structured and unstructured events, contextualize that data in real time, so turning it into something AI can understand, and then allowing you to take action on that data. And as we mentioned, as a customer, if you don't want to put any of this together, then you buy it through VoltagePark as a complete service, and then you just think about the use cases that you want to deploy AI on. So I'm going to hand it over to Nave to talk about how NVIDIA is bringing the software to make this happen as well.
Absolutely, and I think when you look at it, and I don't know that anybody's heard of, has anybody heard of NVIDIA before? Oh yeah, that's right. So, I mean, kind of synonymous with this space, but I think when you look at it, and you look, like you said, Phil, on how the enterprise, I look at VoltagePark and what they're doing, and it really is like the multi-tenancy, multi-department, a lot of it's applicable back to the enterprise, and that's why I think it fits so well with what's happening in the enterprise and what some of the considerations. But Nave, what's the view from NVIDIA on RAG and how it's really transforming enterprise AI?
Absolutely. Yeah, so I will start by saying that it's especially cool to see over the past few years the pattern where enterprises want to connect their data to their AI and agentic RAG in the most recent times. What's cool about the shift between bringing AI to your data, bringing data to your AI versus bringing AI to your data, is that the data gravity is becoming more and more apparent in the enterprise. The data needs to be secure, needs to be maintained continuously. So in fact, bringing AI to your data becomes a more and more evolving and available solution, especially when working with VAST and other platforms. So with that in mind, NVIDIA is thinking, how can we help accelerate that adoption, make the road to production easier, to solve business critical use cases, and get to end customer value. And with that, we focused on a product called NeMo Retriever. And NeMo Retriever is a set of microservices that enable enterprises to bring large-scale enterprise data, whichever modality, if it's text, if it's visual, if it's in PDF documents that have charts, tables, infographics, extract all that information, embed that into their RAG system and vector database, and then retrieve that in real time for business applications and agentic workflows. So all of that pipeline from the models that extract the content from a table to the vector embedding models that take a representation as text and create a vector that represents the data, to storing that data in as fast as possible on a vector database, which requires a lot of GPU acceleration as well. And then in real time, getting the most fine-grained information that you need for a specific task. All that end-to-end is extremely complex. We broke it down into modular pieces and delivered the individual components as well as a blueprint on how to put it all together and work with the ecosystem to deliver that and integrate into different platforms such as VAST and Supermicro. And what's cool about all this platform, as our friends here refer to, is the NVIDIA Inference Microservice, the NIM. The NIM is essentially all the inference software from NVIDIA packed in a packaged container that you can deploy anywhere, on cloud, on-prem, as well in evaluation and production. So that shrinks the time to value quite significantly. And you get the latest models, you get all the inference software from Triton to TensorRT, and all the GPU optimization on top of that, runs on any GPU, and it's enterprise ready with all the security checks and everything that you need to deploy at scale. And especially on that, we have built our latest models with enterprise cases in mind. And one of the key cases is a multimodal retrieval. How do we take all the visual content and retrieve that in real time? And with that, we have a couple of very cool models that we recently released and are top of the major 3 leaderboards in visual document retrieval. And they're all open source and available for anybody to run. And also, if you want to take an enterprise-ready version of them, you can come to build.nvidia.com to get the NIM version of those models to deploy at scale. Lastly, I'd say that the portability and the modularity of the system is very critical. So if you want to use some of the parts to build on your own, to integrate to your own systems, you can go to build.nvidia.com and use that component individually. You can use it all together in a NVIDIA blueprint that shows you how to put it all together and launch at scale. You can try it out on NVIDIA Launchables, or you can go to VAST or one of our other partners and take it as part of our full enterprise storage and AI platform.
Yeah, no, I think that's great. And I think, again, when you start to look at it, and I think Kelly will expand on this as well, is that I think you really hit the nail on the head. You don't want things to go bump in the middle of the night when you're doing this, because you want to keep the GPUs busy. You want to make sure it's reliable and that the storage is consistent. Kind of jump into Graid for us and help us understand where you fit with RAG and what you think the vision is going and how you're playing in that space.
Absolutely, and Nave said it best, data has gravity. Data is important, and moving large amounts of data between workflows like you see here can introduce latency. These guys, Solidigm, are building faster and faster devices, and they're getting denser and denser, and they have higher capacity points. And when you stuff a large number of devices like that into a host or a server or a GPU AI type server, you need to protect that data. And how do you protect it without imposing bottlenecks? And so the traditional ways of doing this require software RAID or hardware RAID, redundant array of independent disks. And these are very common and have been in the market for a long time. The problem is they haven't kept pace with the performance improvements and increases in these environments. And so that's why you start to see things like checkpointing as a way to get around that, because you have to run RAID 0, and so you need checkpoints, and if you have a problem, then you have some sort of latency or fallback period of time. So what Graid Technology did is we created a product called Supreme RAID, and Supreme RAID is a newfangled way of doing data protection. And what we did that's really, I think, kind of unique is we took and wrote our own software RAID stack, and we deployed on NVIDIA GPUs from Nave here. So we are an NVIDIA Inception partner, one of the startup partners. About 25,000 companies are involved in that program. And we're very tightly related to NVIDIA. And we also are an OEM partner with Supermicro. Supermicro sells our products within their servers as everything from a storage server all the way to an AI-based server. The way we solved that problem is we eliminated 2 different bottlenecks. With software RAID, your CPU becomes extremely busy dealing with mathematical calculations for parity, writing all that data down to disk, and then it becomes a bottleneck on read, and it also chews up your CPU, so it leaves less room for your applications to run. What we've done is we've moved that stack onto a GPU, which is much better at mathematical calculations, so we can handle writes very quickly. And then on the read side, we get out of the way of the data path. So hardware RAID creates what we call PCIe lane bottlenecks, where if I have a lot of devices connected to a single device, I may be taking 40 PCIe lanes and jamming that down to something like 16 lanes. We've eliminated that problem with our technology, which is a patented peer-to-peer DMA technology. And on our latest release, Supreme Rate AE, we've incorporated GPU direct storage, which is also known as Magnum IO from NVIDIA. And we actually allow you to buy a software license from us and deploy it on your GPU. The goal of this is to eliminate latencies in these data paths between these workflows, so that, especially in RAG where you're incorporating your own data, there are bottlenecks all over the place in moving data from your own environment to an LLM, and that becomes even more pronounced if you're looking at an edge environment where we may be collecting data real time, writing it quickly, and then turning around and incorporating it into an inference model. How do you do that so fast when you've got a single box in a military environment, in a rugged type environment? And that's really kind of the area that we shine in. So kind of interesting newfangled way of protecting data.
Yeah, I mean, I think it makes total sense, like you said, about the checkpointing and not going back and not, you know, the best checkpoint is the one you don't have to use, right? So I think when you look at that and keeping the GPUs busy really helps out. But to me, let's jump in and understand where Solidigm plays. We kind of got a little bit of a view, but, you know, I'm excited to hear about where you say you're playing with RAG as well.
Thank you, Rob. Solidigm, as you know, this is a company with 30+ years of storage leadership history. I mean, we started with Intel, and now we are working with our partner companies too, also in this area. We're a vertically integrated company. That means we have the media innovation, we have the controller innovation, and on top of it, we are bringing the system optimization needed for the AI workloads, right? So what is really key about us is we are focusing on data center, and in this new age of AI where storage has to be responsive, based on some of the discussion earlier, it has to be also expansive, right? Large amount of data is needed. I think we are emerging as a symbol of storage for AI. The whole Solidigm philosophy is behind that, right? So starting from there, what we look at is the different, you know, when at Solidigm we look at different pipeline stages of the AI workload and see what we are bringing to the market and what we can do in future in terms of innovations. So at the very beginning, you see large amount of data ingest happening, right? It may be structured or unstructured data. That data need to be residing in some reliable storage, right? On top of it, that data also needs to be sequentially written at a very high speed. As you go into the preparation phase, you would like to get more, sequential read and write speed equally higher, right? I think in these spaces, we see high density SSD becoming a very good fit for us, right? And if you go back to 2022, there was a paper from Meta along with Stanford University where they actually talked about this DSI stage, which is data storage and ingest, which constituted about 30% of their power consumption in their overall AI pipeline, right? That is huge, and also it also talked about the increase of the ingest bandwidth 2x over 2 years during that time, and then basically the data size is also increasing, right? So all of these basically creates a good opportunity for us to position a QLC-based product and also on the archive stage where the data is getting stored. So as you guys know, last year we launched this 122 terabyte SSD from Solidigm. I think that is a really good fit for the data ingest, data prep, and the archive stage. As you go into the training phase where there's a lot of random read operations happening, mixed workload happening, this is where we think the Gen 5 SSDs, the high performance, high bandwidth TLC SSDs kind of play, right? And we have launched the PS1010 in that area, right? So while we are talking about it, the key thing is in all these stages, right? If you deploy an HDD-based solution, right, and you deploy an SSD-based solution, you see tremendous amount of throughput improvement. Speakers talked about checkpointing. You can think about 10x to 20x improvement if you go to this type of solution, right? If you think about IOPS scaling, it's almost like 4,000x improvement on the IOPS at a device level. And not only that, you get a 40%, up to 40% TCO improvement moving to an all SSD solution. I think the future of AI is there, and basically what I'm showing here is the overall portfolio where things can actually fit into different phases of the AI pipeline and give you the benefit of power efficiency, performance improvement, and TCO improvement for the overall portfolio. So in the real life, right, think about, let's say you have a 50 petabyte data set deployment. And let's say you are using 12 NVIDIA H100 systems, right? If you do it with HDDs, you can get by with the 9 racks with 54 kilowatt in this particular example. Going to an SSD, 122 terabyte SSD, you're thinking about reducing this overall footprint to 1 rack. And you guys talked about freeing up your resources to GPU, and this is exactly what's happening, right? Making the storage more efficient, not only in terms of space, but in terms of power, up to 90% reduction in power, rack power, up to 50% reduction, increase in GPU footprint for that system. So that's huge, right? And I think that's where storage not only, solves the problem of the data need, but also can bring, with the right storage in play, it can bring the right TCO story and the right efficiency for the overall system deployment. If you talk about, CPU and GPU direct storage, where a lot of training is happening, a lot of, model training and, complex computation is happening, matrix computation is happening. For those type of storage, I think one of the things that we are introducing is the PS1010, which is a form factor with E1.S, EDSFF, slim form factor that goes directly to the GPU and directly to the CPU attached, and then brings up the performance that you need. And it also brings down the cooling costs because it can be liquid cooled. So what I'm showing over here is a device that is purely designed grounds up for an AI installment for single plate liquid cooling deployment. So overall, I think when we talk about storage, we need to talk about the overall workload need across the different spectrum of AI infrastructure, and then make sure that which SSD or which storage is the right fit for that particular deployment. I think that's where the real solution comes in, making these solutions custom built and efficient for future.
Yeah, I think we could talk about liquid cooling versus air cooling all day long and efficiencies and things, but that's amazing numbers. I think, with this, let's kind of jump into the question and answer portion of this. So Rob, let's start with you. I think very interesting because you're not only a customer of Supermicro's, but a lot of the AI folk are, like you said, on going up the freeway here, are members of, or customers of yours. So you're getting to see it from a very different angle from some of the others. But you talked about AI factories, and that can mean a lot of things to a lot of people. What are you meaning about AI factories? And really, how do you see that being different from traditional cloud players?
So in this context, an AI factory is simply how enterprises integrate AI to either augment existing products or build entirely new ones, or to enhance the processes for doing both. We see that enterprises increasingly want to own their AI stack end-to-end without any compromises on data privacy, because that is their only moat. Now, enterprises that have access to the right engineering resources, and we all know engineers are in short supply, and enterprises that are willing to spend a lot of time and money to figure out how to do AI well, of course, can do so. VoltagePark reduces friction by working backwards from real-world customer use cases, one at a time, and giving enterprises a minimal, modular, cohesive AI stack, all the way from the GPUs, from NVIDIA, in racks with storage, with an inference API as an example, and all the associated tooling to run AI workloads in production. The alternative to this is that enterprises would have to spend a lot of resources to first build the AI factory and then figure out how to use it. And in our case, we start with a use case, and our stack, our factory can scale out very easily with more use cases as enterprises onboard them. So that is our vision for AI factory and how it's a little different.
I think a good way to look at it and to jump in is to say, hey, you know, that is kind of a pathway, and I think we're in early days still with AI, and especially with RAG and things. But I think more people are getting into production nowadays. But Ben, kind of help us understand that how Supermicro is enabling enterprise AI, because it is different deployment models, and it really is about meeting the need of those enterprises where they are today.
Yeah, I think the two main key strategies, one is flexibility, and also the other one is validate solutions, right? Just like what VoltagePark speaker just mentioned, AI factories is the future for the enterprise AI. And so, we have that kind of flexibility, either work with the cloud partners or the enterprise want to build everything at a rack scale from scratch, or they want to just scaling up their current enterprise infrastructures. We have this kind of flexibility to provide either L10 GPU systems. We can have them to build rack scale solutions. It can be air cool, it could be liquid cool, right? So this is very important. We offer both the layer 10 and layer 11 for the enterprise sector or in the cloud, right? So customers have that kind of flexibility to choose what's the best way for them, right? Then, we have our in-house engineering capabilities. With our broadest product portfolios, we partner with NVIDIA and Graid to bring the latest and greatest GPU systems to the market. We always want to be the first mover. Then we also work with the partner like Vast Data or Solidigm to bring the eBus, to provide a real-time data streaming platforms for that, right? So the philosophy is the same. We want to really move things faster. And when we say turnkey, we really mean it's turnkey. We not just validate that, testing that, and we make that production ready. As you guys know that we have been deploying a lot of GPU clusters to the largest training model, foundation model companies. So we have that kind of confidence that we can bring these things, be ready, and be the turnkey AI cluster, and we can ship today.
Yeah, I think that is part of the key, and I think we'll come to Tamid here in a second, but I think when you start to look at it, not every organization is VoltagePark and is hosting big AI people around, and they're trying to figure out how to right size it and things like that. But there's still challenges, and to me, give us an idea about what you see as one of the key challenges that folks are going to try to overcome as they go to a RAG architecture.
Yeah, as you go more into the inference and RAG architecture, few things that strike us, right? For example, there is a need of fast access that other speakers also talked about, and also the data set is increasing tremendously, right? So you have to have a fast access path, and you also have to make sure that you address that data growth issue, or somehow you address not having the overall data set being supported by the in-memory, right? And that's where I think some of the new techniques can come into place, where disk-specific ANN models, where you can offload some of these parameters, weights of the training onto the SSD. You can also offload some of the RAG database onto the SSD, and make sure that the SSD is not only helping other phase of the pipeline, but also inside the RAG, it is helping solve those storage bottleneck problems, right? The other thing is, data ingest and archive is also going to grow in this space, also in RAG, and this is where we call every square inch and every what matters, right? So you need to make sure that you have rack consolidation with high density SSDs, and you need to also design for power efficient rack designs, right? So those will be the critical needs for the future. And recently in Solidigm, we worked with Metrum AI, and we did some really good pathfinding work. We were able to use disks and SSDs to offload rack database and model weights onto the SSD. And we got almost 70% increased query per second compared to a traditional, memory-based solution on a 1 million data set. And that too, we did it by reducing the memory footprint by 50%. So there is cost saving there, right? There is also no compromise to performance in this particular case. So I think those emerging cases and innovations is needed where SSDs can be, having new use cases for SSDs to solve the RAG challenges for future.
Yeah, I think that is the key, is how to work smarter, not harder, with there, and to be able to get the most out of all your assets. So Phil, going to come to you. You guys work with a lot of the neoclouds as well as enterprises, and you see kind of how these parallel challenges, what are some of the challenges that you're seeing, or some of the biggest challenges you see with RAG deployments?
Yeah, I think we can put them in like 3 main buckets. So one we hit on a bit, which is the complexity. So it definitely still feels very much like a science project to a lot of customers. So we're working very hard with organizations like NVIDIA and Supermicro to give you a complete, reliable, manageable stack that you can deploy, and then also deploy it in a service provider. Full turnkey, I think, is critical for enterprises feeling comfortable jumping in. The second piece is around speed and scale. So if you have a simple RAG deployment, like the small amount of PDFs, sure, is fine today, but as we're seeing customers tackle more interesting use cases, like I want to do real-time RAG on a bunch of different video feeds, I want to bring agentic AI into React in real time, we're seeing real limitations of some of the open source vector databases. They're just not designed for rapidly inserting, updating, and doing queries at the same time. So we've seen customers like, I have 50 copies of my RAG database that I'm trying to weave together, and that's just not sustainable. So as we shift to real-time and more interesting use cases, you need a more viable, scalable approach to vector databases. And then the last piece is around security and access control. And it's really easy for an enterprise to say, like, you can access a document and I can't, but following those access policies through an embedding process, delivering consistent policies across multiple different types of data sets, if I want to unleash agents in my environment, is really difficult. And we're simplifying that for customers today, and you got to have secure control if you feel confident deploying AI at scale.
Yeah, I think that is key, and it kind of leads into a question for Nave. Like, where does NVIDIA sit, or how do you see in the kind of the vision of being able to have massive scalable data processing with GPU acceleration? What's kind of the target and vector, notwithstanding, vector you're going on here with that?
Yeah, so I agree that one of the major trends over the past few years, and it's becoming more and more apparent as generative models become more popular and generate more data, is the data volume for enterprises is going to skyrocket. And we've seen it going through the past few years. It's going to go exponentially higher. And we really want to get to a point where you don't question yourself when you want to connect or process enterprise data and connect it to your AI. The question should be, why not? And we want to make it as easy as possible, as accessible as possible, and as efficient and cost-efficient as possible. So at NVIDIA, we work on all layers of the stack, from the GPUs to the racks with the ecosystem, to the acceleration software and the overall enterprise software, to get to that value as smoothly as possible. And what's extremely important is the keeping up with the technology as it moves ahead. Right? If the capabilities that we looked at 2 or 3 years ago when we just started with generative AI, and what are the applications that are possible, are completely different from what was possible 6 months from today to today to imagine 2 years from now. So keeping up with that pace and getting reliable software and hardware that can support that through time, and build infrastructure that can support that in 2 or 3 years, is extremely important when it comes to enterprise software and enterprise infrastructure. So what we're doing at NVIDIA is building that software stack to sustain that movement and that growth in the enterprise and in the AI ecosystem in general through standardized APIs, through accelerated software and hardware that just gets better through time. If today we're optimized 90% of the GPU, tomorrow we're going to be 95 and then 97. And that is something that you can rely on NVIDIA to deliver. And on top of that, working with the extensive ecosystem to deliver that value to be as turnkey as possible and as available as possible so you don't need to think about processing your data. It just happens.
Yeah, I think it's totally, you got to keep it busy, right? And I think that's part of what everybody's saying. But one of the ways to keep it busy is protecting it. And RAID has always been that protection there. Why is it so critical, Kelly, for RAID and what Graid is bringing to really the AI and to the servers to be able to help with that as well?
Well, and Nava just mentioned its utilization. So this isn't about our company, it's about a customer's entire journey to developing a system like this. And if they're not really looking at all aspects of it, then bottlenecks will pop up. Anytime you add something faster in your environment, it will just expose another bottleneck. You'll never really get the same full performance out of that. And so we've actually partnered with everybody here in an initiative with NVIDIA looking 2 years out, as he mentioned, on how do we make sure that we're developing storage solutions that will keep these GPUs that we know are coming fully utilized, because they're expensive and customers need to get that utilization. So that's part of it. And we're involved in that whole process because at the end of the data has to be protected, and it has to be protected somehow. We're incorporating new things like erasure coding and other things that companies have seen before, and so we're constantly working to improve our way of accelerating and protecting your data, because that's the most important part.
So we'll stick with you for this group question. We'll start with you, Kelly. And what do you recommend as kind of the number one thing that people, these organizations that are just, I mean, again, we're early innings in RAG and AI and production deployments for most enterprises. What is one thing that you think they should take away from the summit and from focus on as they go down this path architecting for RAG?
They're not alone. There are a lot of people out there trying to do this on their own, and they don't have to. We have a ecosystem of partnerships with Supermicro and NVIDIA and VAST and Solidigm and all of these companies that allows us to help you get where you need to be and do it more easily, do it more quickly, and help you overcome the roadblocks you're inevitably going to hit when you try to deploy something like this.
Makes total sense. To me, same question. What would be one piece of advice to the organizations just starting down this path?
I think a long-term view is needed, and a long-term sustainable view, which is gentler to the environment, and because energy is a big issue for AI deployment, right? So we need to understand what is the right BOM choices that we are making, and what is the impact of that to the environment, right? And having those understanding together and building the future, not for the immediate need now, but plan for time ahead where this is going to be paying us back in dividend, right? I think that is one of the key criteria thing we should be taking as an AI deployment decision.
Ben?
Yeah, I think the enterprise, maybe led by CIO, need to take an honest look about their current enterprise infrastructures. Is that ready for heavy AI real-time workloads? Because in the past, most of the enterprise infrastructure were built for the virtualization, data backup, archiving. We hear a lot of the keywords, the real-time data movement, and keep GPU hungry. So they need to make sure is their enterprise infrastructure ready for this kind of workload, right? So my suggestion is like immediately just talk to us, talk to Supermicro, talk to all the partners, right? We can help them to make a fair assessments, and we can discuss how to move forward together.
So Rob, I mean, you're at the bleeding edge of this every day with customers in the enterprise, having these conversations. What's your recommendation? What's the one piece to take away?
I see a lot of these. And in context of agentic systems, the single most important thing that enterprises should focus on when doing RAG is evaluation and guardrails. In RAG, the generation is the easiest part. Accurate retrieval and augmentation without hallucinating is where it gets tricky, especially as the size of these systems, the data corpus, scales out. So it's extremely important to put evaluations in place across the entire workflow in the agentic system to make sure that we can measure accuracy and know when the agent got it wrong, and to have guardrails in place to deal with when the agent does get it wrong. And the extent to which you do this, of course, depends on the context. But for mission-critical use cases and customer-facing use cases, it's usually advisable to put a human in the loop at the right point so you can know and course correct as needed.
I love that. Phil, you see a lot of this as well. What's a piece of advice?
Yeah, I think we've talked about it, Nave mentioned it, AI is moving so fast that we see a lot of customers reacting to like ChatGPT still, and so many more things are possible. So when I think especially about looking at RAG deployments, today it kind of feels like a RAG deployment is the project. Like now I can search for clips and get context from video feeds, but in our opinion, you're building a feed that will be used by an agent. Right? So I want to think about not just creating performance that a human would like, but performance in real time that an agent would like. And then you think about that different use case, you use like a manufacturing facility. I've created a real-time RAG solution for video and agents watching that video feed. I've got a super smart, super focused, attentive resource, but now they only have one sense. Right? So I want to combine that with other things. I want that agent to be able to hear what's going on in the factory. I want it to feel the temperature. I want it to know anytime there's an alert that flips on a machine to give all of that context. So I think today it can feel overwhelming, but the idea is just thinking about I can build something that I can use today, knowing that I'll be able to plug it into an agentic workflow and get a lot more value out of it tomorrow will be better than just thinking about RAG for humans and then going, I didn't realize that I could do so much with agents, but we didn't build an infrastructure with that in mind.
Yeah, it totally makes sense. I think, again, taking a task by task orientation towards their architecture and, like you said, planning it out, because I think a little forethought goes into it, goes a long way. Nave, I mean, you guys have to have hundreds of these, but pick your favorite recommendation. People are going down the RAG pipeline view. What's your one recommendation to them?
Yeah, I'm going to complement what Phil and Saurabh told here. And what we see when successful enterprises that are successfully deploying AI at scale for their customers is the customer obsession and focus on specific use cases. They are set to leverage AI to solve a problem. And when you do that, it's much, much less confusing of the advancements and the changes and the new agents and so on. You will use the best technology possible to solve your customer problem. And with that in mind, you can set up evaluation, understand what guardrails you need to build for your application, what data you need to connect to that application, and how do you customize the models to really get to the right answers and insights that you need to deliver to your customer. And at NVIDIA, we built this concept called Data Flywheel that enables you to create the data that you need to evaluate these pipelines and customize these pipelines and models, train the models, evaluate the models and the system end-to-end, wrap it up with guardrails, and then deploy at scale. And that only gets better as you use the system more and more, and that feeds into that flywheel that eventually drives more and more value to your customers. So thinking about the end customer in mind, building the use case, and then build a system accordingly, as well as a roadmap through the future.
Yeah, I think that all of this advice is really key on, and actually all highly related to each other, which is key to getting more out of AI, generative AI, inference, and most particularly RAG, as they go down this path. Thank you all for coming on board to this session here. I think this has been great.
Thank you.
Thank you.
And thank you for watching this episode of the Supermicro Open Storage Summit. Stay tuned for more. We'll be back.